Good morning, everyone. Thank you for joining me today. My name is Moez Ali, and today we'll be talking about time series forecasting with PyCaret. That's the agenda for today. I have two demos at the end. A little bit about myself. I have a finance and economics background, and I've worked in healthcare and education for a very long time. Last couple of years, I've been working in consulting and fintech, and very recently, I'm working for a company that builds forecasting softwares and intelligent inventory decision optimization software called and Tweet, which was recently acquired by a company called Zebra. I had product strategy there. I'm very active on LinkedIn, so in case you want to follow what I'm up to, you can follow me on my LinkedIn. Some important links for PyCaret. The most important one is probably the one at the end. That's where I will upload the Jupyter notebooks. This is a good repo where I'll upload the notebooks that I will use in the demo today. All right, so let's begin with what is PyCaret. It's an open source low code machine learning library in Python. So it's like an AutoML. The project started in year 2021. So it's now 2020. So it's now almost 2 years old and have a very big community around it. In terms of functionalities in PyCaret, it's like a typical AutoML that you just pass your data to. It would help you with all the data preparation tasks like missing value imputation or normalization. It would compare a bunch of models automatically to hyperparameters of those models. If you want, you can ensemble your models like blending or stacking. And it has some pretty cool integrations. So you can, with very simply, you can automatically log your entire experiment and visualize it in MLflow, which is another great open source project. PyCaret at the moment support these use cases. We have a classification module that supports classification and regression. We have a regression module. Time series module is new. It is integrated in 3.0, so it's the new module. Unsupervised modules, we have clustering, anomaly detection, association rule mining, and NLP. In terms of project timelines, so we started our first release 1.0 came in April 2020, so now a little bit over 2 years. And in terms of numbers, we started with a very small team, 4 or 5 people, and now we have 78 contributors as of today. We have over 4 million plus downloads and an active, user base of 50,000 on our documentation every day. So it's scaling up to a pretty big community. As I said earlier, we have some pretty solid integrations. So we have integration with Rapids AI, which is an NVIDIA project. We use QML and QDIF libraries to basically support operations on GPU. So when you want to use GPU for your model training and selection, we fall back on QML library by Rapids project. If you're using CPU, we just continue to use scikit-learn models. In machine learning, when it comes to hyperparameter tuning, your search spaces can get really big, and your compute can become a limitation there, right? So you can use a distributed processing framework to distribute your hyperparameter search. So for that, we use a few amazing projects by Ray. Right. In addition to these two, we have a lot of integrations. Think PyCaret as a abstractor over all these great open source libraries. All right, so today we are going to talk about time series forecasting, and we'll see a demo for time series forecasting. But in essence, time series forecasting is when you have a bunch of historical data points, right? And you want to learn the pattern from them to forecast into a future. The graph you're looking at your screen is a number of downloads of PyCaret on a daily basis, and this is over 90 days. from July 2021 to September. And here we have fitted a model, basically trained bunch of model using PyCaret to find the best model, which happens to be a theta forecaster. And you can see we have forecasted, I think, 60 days out or 30 days out. Right, 30 days out, right? It goes until October, last week of October. And the shades is basically confidence interval of the forecast. Not all models produce confidence interval, but this one does. So there are few things to know about time series, right? From practical perspective, is one thing that is very different in time series than regression is your data has a order here, right? So a lot of things that you can do in regression you can't do in time series data. For example, you can't shuffle your data for train test split. You can't do a k-fold cross validation in time series, right? So there's specific type of validations and techniques for train test split. We call it temporal train test split that we have to use. In addition to that, when it comes to model, like there are three broad categories. There's statistical classical models like ARIMA, ETS, theta forecaster, seasonal life. Those are statistical models, moving averages, right? And then there's a category of models that falls under machine learning. So all the regressors like linear regression, lasso, ridge, elastic net from scikit-learn, right? You can use them for time series forecasting tasks, but you have to process your data in a certain way, right? Because if you think about time series, it's not a tabular data, it's a series of numbers, right? You can store it in whichever object you want, but it's a series of numbers basically, right? Over a time step or a temporal axis. So we have to convert it into a tabular format for regression models, for regression models to consume them or train model on them, right? So there you have statistical models, you have machine learning models, and when I say machine learning models, you can basically take any estimator from scikit-learn regression estimator and use it for time series forecasting tasks, given that you process your data in a certain way or prepare your data in a certain way, right? And then the third category is deep learning. That is where your RNNs and LSTMs and these days some other sophisticated methods for time series forecasting. PyCaret only touches the first two. PyCaret doesn't include deep learning models at the moment. All right, so what I want to do now is I want to head over to demo. I will upload the notebooks on this link here, right? But I'll head over to demo and I'll see you there. All right, here we are on Google Colab. I've installed PyCaret pre, which means the latest release candidate for PyCaret 3.0. I will restart my runtime and then let's just get some data to work with. So I will get this function get data and then download this data from PyCaret repository. This is the number of downloads by day for I think for 90 days or so, right? Let's just check total.plot. Yep, 90 days. You can see it has clear trend and some seasonality as well. Let's change a few things in the data frame. So at the moment, if you see the types, the data object is not typed correctly, right? So let's just change that. Data date is equal to pd to date time data date. Is it fine now? Yep. And now let's just set it to index. Data dot set index date drop true is true. All right, and now we can just do data drop. All right, and you can see dates now. So what we'll do now is we will import. First of all, let's just check the version. It should be RC2, 3.0 RC2. Now let's import the module and let's just set up. So I'll pass my data. I want to do threefold cross-validation, sliding window by default, and I want to forecast 12 days ahead, right? So forecast horizon is 12. I'm gonna set a session ID for reproducibility, nothing new there. By the way, PyCaret 3.0 has an object-oriented API as well. So if you don't want to do it this way, you can just do it this way from PyCaret time series import ts forecasting experiment, and then you can just initialize this as an object, and this is basically a class, right? And you can just call off setup on this, right? I am just going to use the functional API. So after setup, we had originally 90 points in this time series. 78 goes to train, 12 goes to test. By default, we are using expanding window splitter, not sliding. Sorry, my bad. So we will be using expanding window splitter threefold on the train set, right? And it would automatically figure out the step size because you have given the fold here, right? And we know the length of train set. We tested for seasonality, which is present. That's why it's true. And there are a few other settings that you can check. The first thing I like to do in time series is basically check some stats. So this is a function, check stats, and this will give you a table of some summary statistics, white noise tests that would tell you if the white noise is present or not, stationarity tests, and normality tests, right? Now let's there's some EDA that you can do, right? So you can just run plot model and it would give you a time series plot, right? You can run at this point, you can also see the train test split plot, which basically tells you these 72 points, right? That was 72, yeah, 78. So these 78 points are train set and these 12 points are test set, right? You can also see cross-validation plot, right? You would see expanding, so three folds. That's why you see these three lines here, three folds, and the orange points are 12 points if you count them, and they are in the holdout set, right? So you see the window is expanding, go from fold 0 to 1. You would see that this is not shifting. That's why it's called expanding cross-validation, right? All right, and there are a few more. So you can check ACF, PSCF plots. You can check diagnostics plot, right? And if you want to see the complete list, just check the documentation of this function here, and you would see all the plots. Some of them you would only use after you have trained a model, right? For example, forecast or in-sample plot, you need a trained model for that, right? Anyways, let's get into the training. The function is same as in other modules of PyCaret, compare models. As you run it, it would train two categories of models. So it will train traditional time series models like ARIMA, ETS, TBATS, right? And it would also train machine learning models like linear regression, lasso, ridge. And for machine learning models, it uses a technique called reduction, which basically tabulate your time series data set into a structure where you can use regression models, right? So you'll see a lot of regression models here as well. Lasso, least angle, Bayesian ridge, decision trees, right? So there is good amount of like 25, 28 models that gets trained. And then you have metrics, MACE, RMSSE, MAE, RMSE, MAE, right? In this example, I think the default metric is set to, I don't remember that, you can check. The default is set to MACE, okay, so the first one. So based on MACE, Theta Forecaster is the best model. You can see the model. It has, oops, sorry, not Theta, best, right? It has some parameters. SP is the parameter. I think it has more parameters.
this deseasonalized parameter in initial level. Okay, so theta is the forecaster. At this point, I can just basically use it for prediction if I want. Let's generate 24 days ahead of prediction. So our last training point was 23rd September, and now I'm forecasting 24 steps ahead using this this model, right? If you want to basically fit this model on the test set now, right? So so just to put in perspective, so far we have trained this model up until here, right? This is my training set, and if you want to use it in production, right, the way you will use it in real life is you will actually forecast the future, right? So what you want to do is after you do your model selection, you have to refit that model on this remaining history, right? This test set here. So just like in other modules of PyCaret, if you want, you can just use finalize model function, and finalize model function basically only does this. It takes the model and fit it on entire data set, right? So now if I call my plot model, predict model, instead of best, if I call it on final best, you will see the prediction starts from 6th October and not 24th September, right? All right, let's take a look at few plots, right? Let's take a look at the forecast plot, which basically shows you the train set, test set, and confidence interval if model supports confidence interval, right? So this is a fit on test set. If you want to see beyond test set, like in real future, you can just add a data quarks argument to this and say forecast horizon, let's look at 36 months in future, right? So now you have this training set up until here, then the next 12 points are test set, and then from here onwards you have the future, right? Few other plots you can see, one of them being in sample, which basically shows you the model fit, right? So orange line is the fit on the training data, and blue line is the actual time series, right? There's a function called create model. So just like compare models is comparing all the models, right? But if you want to train one specific model, you can use create model, right? And you can do something like this, create model ARIMA, right? So it would fit ARIMA. This number here, 1.6079, will basically match with ARIMA here, right? 1.6079. and this is similar to other modules of PyCaret. It will show you the metric by fold, right? But one thing different here is you will see this cutoff, which is basically up until what date we had data in this fold, right? This is kind of useful and add context to time series, right? So if you have domain expertise around what this time series is about, this is very helpful information to see, right? All right, we also have a tune model function. So tune ARIMA, tune model ARIMA. It's a random grid search. You can control the settings like number of iterations or even pass your own grid, right? You can do that. All right, I think this is gonna take some time. There you go. 1.6079 to 1.4281. Yeah, so we improved a little bit. That's good. We have a function called blend model. So if you have, let's say, two models, in this case ARIMA and tune ARIMA, normally you would have different set of models, right? But I'm just showing as an example, you can do something like this: blend models, ARIMA, tune ARIMA, right? Normally you won't pass the same model, right? And you can see that the performance is in between the base model, which gave 1.60, and the best model, which is 1.42. This one is in the middle, right? It kind of makes sense. All right, what else do we have? Yeah, and then you can save your model with save model function, right? You can say my best model, and you would see that it's a pickle file, and you can load it back with load model function, right? And if you just see what is L, L is my pipeline actually, right? Um, that's pretty much it for this demo. One more thing I want to show is if you are dealing with data which is big in size, this function can take a while, right? So one way you can fix this is you can parallelize this function, right? And so there's a project called Fugue. We have integrated with Fugue in PyCaret 3.0. And what this function would do, this is basically a wrapper over distributed processing frameworks like Spark and Dask. So what you can do is you can simply pass a parallel parameter in compare models function, and it will use a Spark or Dask. In this case, in this example, I'm using Spark because I'm using Databricks Community Edition. So it would distribute the function, right? So let's see it. I'm installing these libraries, Fugue, PyCaret, and Cloud Pickle is one requirement of Fugue. I'm also installing MLflow because I will log my experiments. Importing this dataset here, airline, right? I'm using a simpler dataset here, 4.3, forecast horizon 12, and then I'm setting these two additional parameters which would log experiment for me. This is what dataset looks like. It's a monthly dataset, and it basically is number of passengers traveling in that month. It's a very old dataset, so we have 144 points in our data, 132 training, and 12 data points in test set, expanding window splitter threefold, right? And you can see, because of log experiment, you can see MLflow logger here, and it has basically printed a message that the name does not exist, so I have created a new experiment for you. So the experiment is created behind the scene, and I'll show where you can see them at the end. So here I would just create a Spark session, right? And then from PyCaret Parallel, import Fugue backend. And all you have to do is just basically pass the Fugue backend in parallel parameter inside compare models, right? And you can see now this is basically a Spark job, right? You can see it's completed, right? But you can see the logs and maps, right? And we have ensured that the performance that you see here basically matches if you don't use parallel processing, right? So you can reproduce the results either way. Those plots, and now because of that log experiment parameter, you can go to experiment and you can see that you can just go to experiment MLflow, and you can see all these are different sessions, right? I think 25, 26 of them, and you can drill into them, go into details, see the model parameters, model metrics, some tags, model itself, conda file, Python environment file, requirements file, and in fact the results as well, right? Results are also logged here. All right, so I think that's it. I will now open up for Q&A. Thank you, everyone.